Hello students. Today we will start by chapter 3 in a new lecture. Inshallah we will make a proper quick review for chapter 3. Well, chapter 3 is about acid and bases. Acid and bases. These are new terms. Actually, it's not totally new. We have the information at grade 11, but very superficially, we only introduced them. Acid and bases. What are the acid and the bases? First of all, let's see what is the relation between the acid and bases into our life, or by our life. Many stuffs that we are consuming daily as a food, many things or many of our daily foods are acid. They have acidic compound. For example, sour milk contains lactic acid, juice contains vinegar, acetic acid, and lemon, orange, or grapefruit contains citric acid, apple contains malic acid, grape juice contains tartaric acid, and tart flavor in many carbonated beverages, phosphoric acid or benzoic acid. Actually, phosphoric acid used to make a flavor, but about a benzoic acid is mostly a preservative material. So it's used to keep the things from decaying or as an antibacterial growth. Many substances known as a base are commonly found in the household, and for example, many things that we're going to use them for cleaning our things, they are a basic compounds such as sodium hydroxide, NaOH is present in some commercial cleaners known by the common name Lye. And the other bases such as magnesium, this is important, milk of magnesia, aluminum hydroxide, and sodium bicarbonate. They are used as an antacid to relieve the discomfort caused by excess hydrochloric acid excretion by our gastric. Okay, for example, when you feel a burning, irritating in your stomach, and you'll go to a nearest pharmacy around your house, they'll ask you, what's your problem? And you'll say, okay, I feel a burning into my stomach. They'll understand you, what's the problem inside of your stomach. They know that your stomach receives excess amount of hydrochloric acid. Immediately they'll give you something to drink, for example, Gaviscon or some tablet as an antacid. The composition, the ingredients of that medical thing is magnesium hydroxide or aluminum hydroxide or NaHCO3. So they are base and they react with the excess HCl in your stomach, so you will feel comfortable. You will feel comfortable, okay. Milk of magnesia is MgOH by 2, as I said. Now, we have a common properties of the acids. Aqueous solution of the acids are, or they have sour taste. Of course, not by tasting directly, because of most of the acids are the strong oxidant. They can burn, they can denaturize your skin. So you will lose your cute face if you taste the acid directly. For that purpose, we have a machine, we have equipment, instrument to detecting the taste. Okay, acid changed the color of the acid-base indicator, we call litmus paper. So the litmus paper color in the acidic medium is a red color, turns to red in the acidic solution. Some acids react with the active metal to release hydrogen gas, of course, plus salt. So it's important, we will study by the end of this chapter. Of course, acid can react with the base to produce salt and water, but when they react with the base, so these properties will be absent. Aqueous solution of acids can conduct electricity. If you remember, acids are electrolyte, either strong or weak. Strong is a strong acids are strong electrolyte, weak acids are weak electrolyte due to presence of a trace amount of the ions in their aqueous solution. I'm talking about, I mean by weak acids. Well, acid nomenclature. Acid nomenclature, we have two types of the acids, binary and tertiary or oxyacid. For binary acid, we have two atoms. So binary acids are acids that contains two different elements. Well, do encourage two in English. Two different elements, hydrogen and one more electronegative. More electronegative, especially halogens and sulfur also. Well, for nomenclating the binary acids, we have this rule: hydro plus name of nonmetal plus eke plus acid. Well, HF is hydrochloric acid, HCl is HF is hydrofluoric acid, HCl hydrochloric acid, hydrobromic, hydroiodic, hydrosulfuric acid. I think you know how to naming these compounds, but there's a point. When we say hydro, it means we have water. So HF in here is aqueous. This is aqueous also. Aqueous, aqueous, aqueous. Why? Because of we said hydrosulfuric acid. So H2S dissolved in water. But about a hydrogen fluoride in here, it's a gas. It's a gas, it's a gas, gas, gas. Why? Because of we don't have word of we don't have a prefix of hydro. Okay? Hydro. Okay? We don't have this word before starting the naming of that compound. Hydro. Hydro is mean water. Well, so when we say molecule name, it means there's only a molecule of the electrolyte. There's no water. Hydrogen fluoride, hydrogen chloride, hydrogen bromide, hydrogen iodide, hydrogen sulfide. These are aqueous solution, but in here, no, they are not aqueous solution. Here we have a gas molecule. Here they can conduct electricity because of they have ion due to dissolving in the water, but in here there's no any ion. That's why they cannot conduct electricity. So what's the difference between hydrochloric acid and hydrogen chloride? Both are electrolyte, but hydrochloric acid is aqueous solution, can conduct electricity. Hydrogen chloride, no, it cannot conduct. In here we have ion, in here we don't have any ion. HCN is a semi-binary acid, just for your information. Oxyacid is the acid that contains the third atom, which is oxygen. So we have hydrogen, oxygen, and the third element, which is usually non-metal. So for oxyacid, we have a specified system for naming them. Well, hopefully you remember that because of you learned that in grade 11 in chapter 1. Okay. For example, HNO3 is a nitric acid. Look, name of nonmetal. Name of nonmetal, it's nitric, nitrogen. Plus ik, nitric acid. Well, sulfur, okay, sulfur plus IC, sulfuric acid. Phosphor plus IC, phosphoric acid. Okay, chloric, look, chloric acid. Bromic acid. Iodic acid. So, if we decrease the oxygen by one number, so the IC become 2 OUS. Nitrous acid, sulfurous acid, phosphorus acid, chlorous, bromous, and iodous acid. Okay. So we in here we have the same thing is now some common industrial acids. So you have to memorize them, but I will mention something. Sulfuric acid. For example, we have some commercial acid. Sulfuric acid, for example. Sulfuric acid is produced by a large quantity each year. Well, it's not important, but it will be used by a petroleum refining, okay, as a metallurgy. Well, so they are using to manufacturing fertilizer. Sulfuric acid, use it in petroleum refining and use it in a fertilizer manufacturing industry. It's also essential. It will be used in a industry to making paper, paint, dyes, detergent, and in many chemical raw materials. Well, sulfuric acid is used as an automobile batteries. So what kind of the acid can be used in automobile batteries? Sulfuric acid. What kind of the acid can be used in petroleum refinery? Sulfuric acid. What kind of acid can be used to making fertilizer? Sulfuric acid. So like that. But it's very important because of its highly attraction of water. So sulfuric acid used as a dehydrating agent. So it's using for dehydrating drying. So sulfuric acid used as a dehydrating agent. It can absorb water, so it will be used for drying some gases that cannot dissolve in sulfuric acid. We have some gas cannot be, they can dissolve in sulfuric acid, and that gas mixed with water. We wanna eliminate a water. Well, just pass that gas through the sulfuric acid, so the remaining is dry gas. It's about sulfuric acid. The second one is phosphoric acid. Phosphoric acid, look. Phosphoric acid is used directly of manufacturing fertilizer also and animal feed. Phosphoric acid to preparing superphosphate fertilizers is used as a flavoring agent. Well, that's the point of phosphoric acid. It will be used by a beverage industry to making a beverage as a flavoring agent. Flavoring agent. So what kind of acid can be used as a flavoring agent in a beverage making industry? Phosphoric acid. Phosphoric acid. Phosphoric acid. Also, it's used to making detergent and ceramics. So about the phosphoric acid, this is important, and that one also. It's used to making fertilizer and animal feed, and using as a flavoring agent for making beverage. Nitric acid or nitric acid, that's the same. Pure nitric acid, it's a very volatile solution. It's a very volatile liquid, and it's colorless. It's unstable, okay? But if we dissolve in water, it will be more stable because of the concentration reduced. Nitric acid stain proteins yellow. So if nitric acid exposed to a protein, immediately the color of the protein becomes too yellow. For example, our skin, if we put a drop of nitric acid, it will be a yellow. Well, it has a suffocating odor. You will feel choking when you inhaling nitric acid vapor. Stains skin also, and it can cause a serious burn because of it's very strong. Nitric acid is used in making explosives, especially in a TNT industry, trinitrotoluene. So nitric acid used as to making explosive materials. It stains protein yellow. It's unstable. It's volatile. So that's the point. Initially, nitric acid solution is colorless, but by passing the time, okay, by passing the time, the color become yellow. Why? Because of it gonna decompose to a brown nitrogen dioxide gas. Why? What kind of acid initially is yellow, but by passing a time becomes to initially is colorless, but by passing a time becomes a yellow nitric acid. Why? Because of it gonna decompose to a brown nitrogen dioxide gas. That's about the nitric acid. Hydrochloric acid or muriatic acid. Well, this is stomach acid. Stomach acid. Industrially, hydrochloric acid is important for pickling and iron steel. Well, industry general agent, food passing through the concentrated hydrochloric acid. Well, it will be used in a swimming pool, so don't forget about that. What kind of acid is used in a swimming pool? Look, it uses to maintain the correct acidity in a swimming pool. HCl, used by a swimming pool owners to maintaining a correct acidity of their pool. So that's about some common commercial acids. Acetic acid also, it has some points, so please memorize them. Well, for acids, we have two kinds of the acids, strong and weak. Strong is a strong electrolyte. Strong acids are strong electrolyte. It ionizes completely. It ionizes completely. Strong acid ionizes completely, okay, in aqueous solution to produce a high amount of the ions, mainly hydronium ion, H3O. For example, we have HCl, HBr, Hi, HNO3, etc. They are strong acid. If we put them into water, so immediately they're going to ionize completely into their individual ions. So you can say that the concentration of the electrolyte is 0, 0, 0. Well, this is our prediction. It's not practically. So what about the ions? The ions present by maximum concentration in the aqueous solution of strong acids. Look, we have HBr. HBr is strong acid, and here we have a very weak a very weak bond, a very weak attraction, weak bond. So it can break very easily when we put into water because of the attraction force of water can overcome that strength of the bond. So we should use a single arrow because of its strong electrolyte. It completely ionizes, completely break to form H3O plus Br negative O. So now in here we have minimum concentration, but in here we have maximum concentration. Why maximum? Okay, because of it completely ionized to form the ions. So now instead of the molecule of the acid, we have only the ions. So the ions present by the maximum concentration in the aqueous solution of strong electrolyte, like strong acid. So, what kind of particles are present in the aqueous solution of strong electrolyte? Okay, of strong electrolyte, such as strong acid. Okay, for strong acid, the molecule of acid will be 0. We don't have any molecule of the acid. So the only thing will be positive and negative ion. For example, look, we have this question. In the aqueous solution of HCl, okay, explain how many particles do we have, what particles have the maximum concentration and what has the minimum concentration. Okay, look, HCl aqueous, it means HCl plus water, H2O, to producing H3O plus Cl negative. Because of its strong electrolyte, it ionizes completely, so here we have 0. There will not be any remaining amount of HCl. So we don't have HCl. We don't have any HCl. Okay. And this is solvent. We're not concerned with the solvent because of its maximum amount. Always it has a maximum amount. It's solvent. But I'm talking about the particles of iron, of the ions. Look, here we have the maximum concentration of the ions. So what about the molecule of the electrolyte? No, it's zero. Why? Because of its strong electrolyte. You see, it's really serious. It's really important to memorize strong and weak acids. But in contrast about the weak acids, for weak acids, for example, HF, in here we have a strong interaction. So weak electrolyte has strong interaction between its molecules, but strong electrolyte has weak interaction between its molecules. That's why it ionizes completely. But in here, because of in here we have a very strong bond, so it will ionize by a small quantity. For example, we have this amount of HF. Because of its weak electrolyte, it has a strong bond, so only a small amount of that electrolyte will be ionized. HF plus H2O to producing, look, I'm using double arrow because of its weak electrolyte, to forming H3O plus F. Now, what kind of the particle in this reaction has the maximum concentration electrolyte by itself? Look, only a small amount is ionized. So the remaining will be HF. Now it has a maximum concentration, but in here we have minimum concentration of the ions. Because we have minimum concentration of the ions, that's why an aqueous solution of the weak electrolytes conduct electricity poorly. Due to this problem, we have a small number of the ions. Due to presence of small number of the ions in the aqueous solution of weak electrolytes, so we get poorly electric conductance. Well, another example, for example, we have HCN or any of these acids, whatever. Because they have a strong interaction between positive and negative ion, so they ionize only by small amount. So the large concentration is the molecule of the electrolyte. The smallest concentration or the lowest concentration is for the ions. It's about weak electrolyte, but we have exact reverse thing in case of strong electrolytes. Good. Now, look, we have HCl. HCl is strong electrolyte, so zero concentration remains because of it completely ionizes to form its ion. So we have maximum concentration in here, we have minimum concentration in here. But for HF, no, we have maximum concentration for HF, minimum concentration for the ions. Look, the electric conductance depends on the number of the ions. So what is your expectation about the electric conductance for these two different aqueous solutions? In here we have large number of the ions, in here we have small number of the ions. So it should conduct electricity very well, but in here we have poor electric conductance because there's a small number of the ions. Why? Because of the electrolyte is weak due to their bond strength. Now, acidic strength depends on the polarity between hydrogen and the other element. Of course, bond energy. As much as the bond energy decreases, the acidity increases. As much as the bond energy increases, the acidity decreases. So there's a strong, there's a reverse relation between them. Okay. Presents in dilute aqueous solution of weak acid. Oh, for weak acid, we have a molecule of the acid by a maximum number. Of course, we get positive ion and negative, but by small numbers. Well, we have an ion in the aqueous solution of weak electrolyte or weak acid. Yes, that's right answer. Acid molecule, yes, by maximum concentration. Hydronium ion, yes, we have that one. So the right answer is all of them. But presents in dilute aqueous solution of strong acid. Oh, for strong acid, what will happen to the molecule of the acid? It will destroy completely. So we don't have any molecule of the acid in here. So there will be only anion and cation. So the right answer is D. D is the correct answer. This is not corrosion. This is correct. Okay. In this reaction, HF plus H2O to producing hydronium plus fluoride, this blank has the maximum concentration. Well, it is weak electrolyte. So if we have weak electrolyte, which of these particles should have the maximum concentration? Of course, the electrolyte by itself. HF. So HF has the maximum concentration. Phosphoric acid has 3 hydrogen atoms and it's weak acid, but HCl has 1, but it's strong. Well, it says that H3PO4 with 3 hydrogen atoms, but it's weak acid. But for HCl, there is only 1 hydrogen atom. 1 hydrogen atom, but it's strong. So what's the deal with that? Well, the number of hydrogen does not indicate the acid strength. Only producing the ions decides that the acid is strong or not. In here we will get more ion, but in here we will get less ion. That's why this is strong, because we have more ion, but in here we have less ion. Okay? Depends on the ionizability power. As much as the ionizability power increase, the acidity increase. So the ionizability power of HCl cannot be compared by H3PO4 because it's much more stronger than H3PO4. Now, properties of the bases, aqueous solution of the bases taste bitter, but not by tasting directly because of it's too strong. It burns your skin sometimes. Bases change color of the acid base indicate a paper to the blue, but in the acid we have red color, but for the base we have blue color. Dilute aqueous solution base feels slippery. It means very smooth, just like a soap. And also bases can react with the acids to form salt and water, but when we react with the acids, these properties become, they will be absent. Of course, same as the acids, for the bases we have strong and weak. But for strong bases are ionic compound. They can completely ionize or dissociate. Well, I remember for ionic compound we have dissociation, not ionization. So they ionize completely. They composed of hydroxide, anion and cation that came from the metal. Strong bases, okay, nomenclature. Well, it's very easy. I don't like to waste our time by talking about nomenclature of the bases. There's very, very important things. We have to use our time for the important things. Weak bases are molecular compound, but strong bases are ionic compound. But okay, if weak bases are molecular compound, so they ionize or they dissociate. Of course, they ionize. Molecular compound ionize, but ionic compound dissociate. Okay? Look, it's molecular compound. Hopefully you know how to make a distinguish between molecular compound and ionic compound. So I'm gonna show you very, very important points because of we have many things. Okay. About molecular compound and ionic compound. Okay. For molecular compound, we have strong acid, weak acid. Well, molecular electrolyte, of course. Weak acid and weak base. But in here, for ionic compound, we have strong base and salts. Okay. Ionic compound that can ionize completely. Strong base. That can dissociate completely. Strong base. So they are dissociate. But they are ionized. Understand that? So write that thing, transfer it into your notebook exactly like this. Let's answer some important questions. NaOH is, okay, NaOH is a strong base, first of all. Strong base, okay. It is ionic compound. It will dissociate completely. Why? Because of it is strong. So it will dissociate completely. Well, it's ionic compound and completely ionize it? No, not ionization. Until here it's correct, but in here it's not correct. It's ionic compound and slightly ionized. No. This is not correct. It's not correct. Molecular compound and slightly ionized. No, it's not molecular compound. It's not slightly, it's not ionized. It's totally wrong. Ionic compound, it's correct. Completely dissociated, yes, because of its strong and it's ionic, it will dissociate. It is strong, it will completely dissociate. It's ionic compound. So the right answer is D. D. HCl is, okay. HCl, I remember, it's molecular compound. Molecular compound, okay. HCl is a molecular compound. You know that? It will ionize. It's completely, because of it's strong. Okay. So it's molecular compound and completely dissociated. Right, it's molecular compound and it's completely but not dissociated, ionized. Okay? It's molecular compound, yes, it's right. Slightly dissociated, no, it's not slightly, it's not dissociated. It's ionic compound, no, I will not read this continuously because of its ionic, no. From the first, by starting this answer, it makes a mistake. So I'm not concerned with the other. Molecular compound, yes, it's right. Completely, yes. Ionized, yes. Right answer is D. NH3. Oh, NH3 is weak base. So, it's molecular compound. It's partially ionized. Why partially? Because of its weak base. Weak electrolytes are partially doing things. Okay. It's molecular compound? Yes, it's right. And completely ionized? No. I don't agree with completely. I agree with partially. Molecular compound? Yes. And slightly ionized? Oh. The right answer is in here. That's the floor that we are looking for. Molecular compound and slightly ionized. Okay? Well, now about the definitions of acid and the bases, about the definitions of acid and the bases, I prefer to talk about the definition of the acid and bases by different lecture. Okay? So it's really important. That's why I want to spend more time in here with that man. So be a patient until the next lecture. Inshallah, I'll see you again and I'll come to your homes gladly. هیوادارم سوتان لێ بینی بێت تا ئەو کات بە خواتان دەست پێرم. خواتان لەگەڵ.